Hi there. The purpose of this short little video is to introduce you to Chapter 4, and the whole point of Chapter 4 is to introduce you to Chapter 5. In Chapter 5, you might want to get excited about because maybe learning all about those covalent bonds weren't your cup of tea, but Chapter 5 we're going to spend a lot of time on. Chapter 5 covers organic molecules, but you more directly experience organic molecules in your everyday life as food molecules. So you can think, so three terms, you can call them organic molecules, you can call them molecules of life, or you can call them food molecules. So hey, let's start talking about food soon. All right, so what are some characteristics of organic molecules or molecules of life? First of all, as I've implied, they are found and produced by living organisms. So do any of you guys like to hike? So let's say you were hiking one day through John Bryan State Park and you saw this really cool looking rock and you go to pick it up and you find it squishy and you examine it and you see it's made out of lipid. Whole rock made out of fat. Would that freak you out a little bit? It would me. Because we know we find fat in the body of organisms that are alive or were once alive. Or likewise, if you like to go rock climbing, what if a piece broke off and you took a little taste and found out it was literally Candy Mountain? I mean, you don't think mountains are made of sugar typically, right? Because you find sugar in the bodies of plants. So these food molecules, right, are found in organisms that are alive or were once alive. Okay, they tend to be large and complex. So gone are the days we're going to draw those little protons, neutrons, and electrons. We're going to draw whole atoms, right, and covalently bond them to other atoms, etc., etc. All right. Speaking of which, when you build an organic molecule, you'll see that they often have a large carbon backbone. You'll see carbon covalently bonded to carbon, 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 carbon. And the term you often see is the tetravalence of carbon. Tetra, you might know, means 4. Valence refers to the outermost electrons. Well, what you should know by now, if you've done your little mini assignments, is that carbon is only stable if it forms 4 covalent bonds. 1, 2, 3, 4. All right, so every carbon atom is stable if it's forming 4 covalent bonds, which gives it an interesting feature. As you can see, you can have a whole chain of carbon atoms all lined up, holding hands with their friends, not socially distanced. And even when you have a whole chain of carbon atoms, they still have a hand free to hold on to other atoms. So you can make these large chains and attach other atoms to the side. All right. So what do you think of when you think of food molecules? What did you have for dinner last night? Well, I think most of you associate protein as a food molecule or organic molecule. And you can probably think of what you ate yesterday to get your protein. Now, what about carbs, carbohydrates? When you think of carbs, what do you think of? Maybe you think of pasta, which is made up of starch. All right, that's one example. Carbohydrates include sugars, starches, and fiber. So that good old fiber is good to keep you regular and keep things moving. All right. Then there's nucleic acids. Okay, nucleic acids, we have 2 examples of that, DNA and its cousin RNA. And the last group we're going to talk about of food molecules or organic molecules are lipids. Now I'm betting when I say the word lipid, you're thinking fat, which is good because fats are lipids. But a lot of you might be surprised to learn that cholesterol is also a lipid. So there's 2 types of lipids. There's the fat family and there's the cholesterol family. And they are both types of lipids. All right, now, but before we dive into these food molecules, we have to explore some characteristics of some simple, basic molecules. And unfortunately, we normally play around with models in class, and we won't be able to do that this year, but we'll sort of do it virtually in the next video. So I will see you there.